Next question is, given the matrix A is equal to 2, 0, 4, 1, 3, 1, and we have another matrix B is equal to 4, 5, 0. Which of the following is or true? Options are being given. We need to find out the correct options or option. So we have the matrix A is, we have 2, 0, 4, 1, 3, 1 as the elements in the matrix A. In the matrix B, we have the elements 4, 5, 0. Let us see the first option. First option says the product of A times the transpose of B is 8, 19. That is, we have the column matrix with elements 8 and 9. Let us check the first one. So in the first one, so A is this. So can I write A B transpose is equal to, so we have 2, 0, 4, 1, 3, 1. Now what is the transpose of B? So by transpose of a matrix, we mean when we interchange column with row or row with column, we get a transpose. So if these are here rows, okay, row matrix, it becomes column matrix. So we have 4, 5, 0. Interchanging rows with columns or columns with rows gives us the transpose. Now the product of these two, first we need to see whether the product is defined or not. Okay, so for two matrices, rather for two matrices, the product is defined if the two matrices are conformable for multiplication. Okay, so by conformability, what we mean? By conformability, we mean that the number of columns in the first matrix should be equal to the number of rows in the second matrix. Or we say A and B transpose, the product is defined or exists when the number of columns in the first matrix is equal to the number of rows in the second element. In the second matrix. So what are the number of columns? 1, 2, 3. And what are the number of rows in the second? 1, 2, 3. Okay. So the order is here. We have 2 by 3. And here we have 1, 2, 3, 3 by 1. Okay. Since the number of columns is equal to the number of rows, the two matrices are conformable for multiplication. So we can do multiplication. And what will be the order of the product of the matrix? That will be equal to 2 into 1. So we'll get 2 into 1. That means we will have 2 rows and 1 column. So let's do the multiplication. How do we do the multiplication? We multiply rows with the columns. So this row is to be multiplied with this column. So we get 2 into 4 plus 0 into 5, 0 into 5, plus 4 into 0. Similarly, we get, then we multiply this row with this column. So we have 1 into 4 plus, then we have 3 into 5 plus, then we have 1 into 0. Here you can see, and if I write it here, so we get 2 4s are 8. So this is 0, this is 0. So we get 8 here. Here 4 1s are 4, 5 3s are 15. 15 plus 4 is 19, and it is here 0. So we get 19. Now let us see the order of this matrix. So we have 2 rows and 1 column. So 2 into 1 is the order of this very matrix. That means option A times the product of the transpose of B is equal to 8 upon 19. This option seems correct. Now let us check the another, because here the multiple options can be true. So first one is true. Let us go for the second option. Second says as A B transpose is defined. As I have told you earlier that since A times BT, that is the product of A and the transpose of B, the product of these two matrices is conformable If it is conformable, that means the product is defined. Okay, earlier we saw that we can do the multiplication with A times the transpose of B. So this option is also correct, because AB is defined if the product is conformable. Conformable means simply if the number of columns in first matrix is equal to number of rows in second matrix. Okay, I will not repeat it. So if the product is we say two matrices are conformable if they are conformable for multiplication. When this condition happens, if they are conformable, that means they are defined. Since we saw in the earlier option the product came out to be 8 upon 19, so it is defined. Let us see the third option. So we have B times A. So first we write 4, 5, 0 and we multiply it with A is 204, 131. Here, for the two matrices to be conformable for multiplication, what is the condition? Number of columns in the first matrix should be equal to the number of rows in the second matrix. We have 1, 2, 3. We have 3 columns here, but we have only 2 rows here. Okay, so they are not conformable. That means they are not, the product is not defined. So this option is incorrect. Now let us see the last one. Last one says B times A transpose. B times A transpose. Okay, so B is this 4, 5, 0. This is our matrix, and the transpose of A, interchanging rows with columns. So we have 204, 204 column. Then we have 1, 3, 1. Okay, this is A transpose. Let us see the conformability. Number of columns in the first matrix are 3 and number of columns in the second matrix are 3. That means we can do the multiplication, and the order is here 1 into 3, and here 1, 2, 3 into 2, 3 into 2. Okay, so the order of the new matrix will be 1 into 2. That means we will have 1 row and 2 columns. Let us do the multiplication. So we multiply row by column. So we get 4 into 2 plus 5 into 0 plus 0 into 4. Okay, so 1 row, then we have 2 columns. So this is 1, another will be here then, because we have 2 columns. So this is 1 number, we will have another here. So now we have 4 into 1 is 4 into 1 plus 5 into 3 plus 0 into 1. 0 into 1. Okay, let me write it here. Plus 0 into 1. And this will be our matrix. So this is 4 2s are 8. This is 0. This is 0. Here we get 5 3s are 15 plus 4 is 19. So we get 19. Here you can see the order is 1 into 2, 1 row and 2 columns. So this option is also correct. So we have 1, 2 and 3. I don't see if there was another option. So I guess E option was also, I didn't write it here and I don't know this time.